This is just defining it for you again. What is a rational function? That might be a good test question. So what is a rational function? It's a ratio, meaning a fraction, of two polynomial functions. They can't be zero, and they don't have any common factors. So we're going to figure out what happens when they have a common factor after vacation. But for now, they don't have any common factors that can be canceled, and they're just sitting on top of each other, and they're both polynomial functions. So it says, consider the function 1 over x. So that is one of the parent functions that I said I was going to teach you about this unit. We kind of looked at it briefly. Without graphing it, how could you determine its domain? So what is domain? The allowable x values. X cannot be 0 because then I'd have 0 in the denominator. So anytime you have a square root, you can't have negatives. Anytime you have a denominator, you can't have 0. All right, so let's graph this function using a table of values. So let's generate a table of values first. If I plug in -2, I'm going to have -1/2 as my y value. If I plug in -1, I'm going to have -1 as my y value. But what happens if I plug in -1/2? So what is 1 divided by -1/2? You flip and multiply by the reciprocal. So you actually get -2 as the result, right? 1 divided by -1/2. How many half dollars are in a dollar? There's 2. All right, so what if I take 1 and I divide by -1/4? So I would flip it, right? And multiply by the reciprocal, and now I have -4. So basically, the smaller the fraction that you divide by, the bigger the output. If I divide by 0, I get error or undefined. And then, isn't this going to be symmetrical? So if I divide by 1/4, I'm going to get +4. If I divide by 1/2, I'm going to get +2. 1 divided by 1 is 1. 1 divided by 2 is 1/2. So it's a symmetrical graph over the origin. So let's plot those points. So error at 0 means that there's actually this kind of dotted asymptote at the y-axis. So you can't touch the y-axis. So plot those points and see what your graph looks like. So this is a parent function. Okay. So at -2, I'm at 1/2. Oh, sorry, -2, I'm at -1/2. Whoops. -1, -1, -1/2, -2. Kind of goes like this. Ignore that point right there. And then 1, 1. So it's 2 elbows. I think 1, 1 and -1, -1 are kind of your key points. And then if you notice, it slides closer and closer to the x-axis, but that's actually another asymptote. So the two axes, x equals 0 and y equals 0, are your two asymptotes. So an asymptote is a line that you approach, but you don't touch. So I'm approaching these lines, but I never actually get there. So that's the parent function, and then all the changes that we make to these functions moves this around and changes where the elbows are. All right, so end behavior. Determine the end behavior. What does the end behavior do? As x goes to positive infinity, what is this line approaching? So as x approaches infinity, the right side of the graph, what's the right side of the graph approaching? Is it going up or down? Or is it approaching a number? What is this arrow approaching? Yeah, it's approaching a y value of 0, right? I'm getting lower and lower and lower and lower. So the right end, y is approaching 0. What's happening on the left side of the graph? As x approaches negative infinity, what's happening? Y is also approaching 0, right? So sometimes end behavior is not going up or down like a polynomial. It might be approaching your asymptote line. And what's the range of this function? So as I scan from top to bottom, are there any restrictions for my y values? What can y not be? 0, right? So just like we said up top, the domain can't be 0 and the range can't be 0 because those are your two asymptotes. So rational functions are one type that have asymptotes. An asymptote is a line that a curve approaches as it heads towards infinity. What asymptotes do you see and how do they relate to the domain and range? We basically just talked about that, right? These are our two asymptote lines, so they are restricting the domain and range. All right, so I want to talk about just a couple simple transformations of that graph. So we already know our transformation rules, right? Left, right, up, down. I don't know why this printed so small, but what does the -1 do when it's next to the x? What do you think that does? What's our transformation rule? When it's in parentheses next to x, what does it do? Shifts it to the right. So our whole graph needs to move right 1. And then what transformation rule do we have when it's outside adding 2 to the function? Up 2. So you can apply those transformation rules to this new function that you've never seen before. And so you're going to shift your asymptote right 1 up 2, and you're also going to shift those 2 key points that we talked about, right? To me, the key points are the 1, 1 and the -1, -1. So we're just going to shift everything right 1 and up 2 units. So if I shift my asymptote right 1, I'm now going to have an asymptote at 1. And if I shift everything up 2, I'm now going to have an asymptote at +2. So basically, that just moved my x and y axis for me. So because I moved the x and y axis, when I shift my 1, 1 point, right 1 and up 2, it basically is going to land at kind of 1, 1 for that new set of kind of axes. So my 2 elbows are going to go through those 2 key points. So I moved my asymptote right 1 and up 1, and then those 2 points also moved right 1 and up 1. And it says, give the vertical asymptotes the domain and range and plot 1 point on each curve. So the vertical asymptote is going to be at x equals 1. How would I write the domain? So my domain restriction is what? What can x not equal? X cannot equal 1. Won't that make the denominator 0? Right? So x cannot equal 1. And what can y not equal? Y cannot equal 2. So that's just shifting the parent function. The rules that we're going to be studying are a little bit different than this, but I think it's good to look at just the basic parent function with our transformation rules. See if you can do B. B is very similar to A. C has that extra transformation of a flip, but I think we can do it. So try B. So think about, are you going left or right? Are you going up or down? Shift your asymptotes and plot your 2 points and curves. Your vertical asymptote, your domain, and your range. So my vertical asymptote is now at -3. So that makes my domain x cannot be -3. And my range is y cannot be -1. So you write your asymptote as an equal sign because that's a line, but you write your domain as a restriction. X can't be -3 because the denominator will turn into 0 and we'll get our error message. All right, the last one has 3 transformations, including this negative sign in front of the parentheses. What way does that flip my graph? A negative sign over the upside down over the x-axis. Yep, x-axis flip. So see, we're reviewing our transformation rules that you can apply to all those functions on the Unit 1 test. So this is going left 1, this is going down 3. So we're going to go left 1, down 3, and then instead of putting the points here and here, you're just going to flip-flop where they are over the new kind of x and y axis. I'm calling them. They're asymptotes, but I just pretend that I'm shifting my whole axis over. So here's left 1, and here's down 1, 2, 3. And then instead of going, these two, I'm going to use these 2 points as my kind of flip to make my elbows. So we've got that x equals -1 as my vertical asymptote. My domain x cannot be -1, and my range y cannot be -3. Domain and range x and y, some of you were flip-flopping those on the test, but it goes in alphabetical order, x, y, domain, range, so that you don't forget. So that is where I'm going to stop.